Hello and welcome to another episode of Coding Geeks. I'm Gizmo and there is also
X.
We're both from Vichel and we show you today the ASCII encodings. Okay, lesson 4, ASCII encoding. The computer can only work with numbers and people do work with letters and words and characters. So we need a mapping from numbers to human text. So we need a conversion from numbers to human readable text. Now please open your Brave browser and show us an ASCII table. Okay, so let's imagine I want to send you an email with the text hello. A computer can only work with numbers, so I do not send H or hello, I send you numbers. And the first number I send you is the number 72. Yeah, I send you an H. The next number I send is number 69. Then I send an L, this is number 76. Guess what? I send it 2 times, and then I send you an O, which is the number 79. And then your computer receives it, sees the number, okay, number 72. Oh, I display an H. Oh, an E-L-L-O, hello. That's how computers work. They can only work with numbers, and ASCII is a table or encoding from numbers to characters. Let's look at the draft again. Okay, so ASCII encoding is the first encoding that solves this problem or addresses this problem or the need. It's not a problem, it's more a need because it's solved, no problem anymore. So ASCII is 1 byte per character. We remember 1 byte from the previous video, and in the original, only 7-bit of the 8 bits were used. The 8th bit, the most significant one, the 128, is a checksum. Now let us look at the ASCII table again. It's a bit sorted, put in categories maybe. If you look at the most left from 0 to 31, these are all controlled characters like tab, enter, backspace, some outdated stuff that no one needs anymore. Then in the second group, we have numbers and number operators or special characters. In the third, we have uppercase characters, and then we have lowercase characters. So let us look at the draft again. These are 128 characters, but in the real world of planet Earth, we have way more characters, like Chinese, emoticons, like smileys. But ASCII cannot do smileys. ASCII, if you look at 8-bit ASCII, it does a bit more. For example, number 149, the accent O for French. So this extended ASCII can a bit French maybe, but it's not used. It's not used anymore because, let's look at the draft again. We have way better encodings like WinISO. WinISO is like 16-bit encoding with mappings for different countries. There's like a German Win, French Win, and so on. Then I want to mention another encoding, which is very nice. CBM ASCII is Commodore Bureau Machines ASCII. This is very simple. A is 1, B is 2, 3 is C, and so on. UTF, this is very important. So we need character encoding for any language on the planet, for emoticons, maybe country flags, and maybe other stuff, icons, maybe. There is Unicode. Unicode is an official mapping of all the characters you can imagine. And UTF means Unicode Transformation Format or similar. It means how to map the binary to the Unicode. Please Google for UTF-16. UTF-16 is 16 bits, and it can map. This is the maximum number of characters for UTF-16, and it can map all these values on the Unicode, and Unicode is just like mapping how to which character to display. And then there's also UTF-32, 4 billion. That's enough for all the characters. The problem is if you use UTF-32, every character needs 4 byte.
Why is that?
So every character needs 4 byte now. For English and European languages with the Latin letters, we can save a lot of space, and UTF-8 is a special encoding. Open the calculator again. 2 to the power of 8, only 256. But everyone uses UTF-8. Why and how? UTF-8 is compatible to ASCII, but not the extended ASCII. It's compatible to the 7-bit ASCII. And instead of a checksum bit, we have a bit O. We need another byte after this. you can chain bytes in UTF-8, and MSB of 1, the highest bit of 1, means, oh, a next byte is following for this character. And so you can construct characters of arbitrary length, and on ASCII you save space, and it's compatible with ASCII. Do you want to write a little program now in your lessons? Okay, so I want you to implement 2 functions. Line 2, function number to character, or to char maybe. Character is a bit long. Naming is very important in programming. You have to choose very good function names. Always you need to be consistent and fine. And our first param is a number. We name it number. So basically, we want to map a number to a string. We need a mapping. And the mapping can be simply an array, like 0 is I don't know yet. And 32 is a space. So we map the 32, we map to space. And we simply return mapping of number. Does it make sense?
Yes.
So now we can fill out the ASCII table here. In the end, we can also do a string. The first, we don't know, we don't know, we don't know. Or we can say the first 32 characters, we don't know. And then comes a space. And then we return a string slice of the ASCII string, starting at number with a length of 1. This would also work, but then you need a string here like this. If we do a 31, it will be a question mark. What do you think is the output?
Question mark A
No,
maybe.
I intended A space A. Let's run it, exactly. I was right. Okay, so delete line 4 and 5. $ASCII string equals backslash x 00. And okay, and this is a string with a 0 byte. And if we do the next, this is 1 character. This is 1 character, the 0 byte. Now at a character with a number 1, the second character of the ASCII encoding is the, look at the ASCII table again. So we added this one exactly. A null. 0 is a null byte. It's important, it terminates strings. Then we add start of headings, the 1 byte appended to the ASCII string. Please line 7 new. We do a for loop from 0 to 128. Line 8, $ASCII string, append, CHR, ASCII string dot equals CHR, $I. And now let us do line 14, do the hello numbers. And now we line 11, return substring. So as first parameter, we take the ASCII string. And where should it start to cut? Please do delete line 6. And ASCII string should be an empty string. And in line 9, do echo ASCII string and run it.
Should we delete this?
Yeah, delete this, yes. And line 3 is also ugly. Now, this is your ASCII string. We just append every character from 0 to 127.
So now we have the ASCII table.
Yeah, line 8. You see the warning in line 8? Where should your substring slice start? You can slice the string, and which character do you start? We need to return a single letter from the ASCII string. You have the whole letters all in ASCII string. Now, which letter do we want? Which position? We have a function and it has a parameter number. We want to return the string for the number. And how long shall the string be? If you hover over substring again? Oh, well, run it. Delete line 7, run it. Do you understand this?
No.
This is because now it returns from H to the rest. Then it returns from E to the rest. Then from L to the rest. From L to the rest. From O to the rest. Line 10. To echo number to char, append a new line. Yes, and the same for the others too. Now more clear. Now read the first letter of each line.
Allah. Okay.
Because you need in line 7, if you hover over the function, the third parameter length, if you omit it, if you do not give a length, it takes the rest, and we need a length of 1. Any questions?
No, that's clear.
Okay, now I want to tell you another function. It's ORD, line 15 new, echo. The function is named ORD, the string H for hello, only one character H. It takes only a single character. A string, you need H as string. And uppercase, please. Save and run. So this is a function for the other way around, char to number. Open the draft, please. Okay, so last thing to mention, in PHP, UTF-8 is used. Java uses UTF-16. Windows uses 16-bit encodings. Any questions?
No, thank you very much.
Okay, then we thank you for watching and hope to see you next time. And do not forget to visit Vichal and hack the planet.